Jai Hind to all, my dear students. Myself Dr. Neelesh Kumar Gupta. I am working as a professor in Department of Electronics and Communication Engineering. Today, I will start a lecture on digital communication. Its AKTU code is KEC 601. Now, in this lecture, I will tell you about the random variables. So, digital communication is the basic paper and basic subject of you for your electronics and communication engineering branch. So, in this lecture, I am taking the random variable. This is the title of this lecture. It's very important to understand the meaning of random variable. So, in this lecture, I will tell you all the things used in random variable under the digital communication subject. So, let us start. So, firstly, explain you the block diagram of digital communication system. What is digital communication system? Because everywhere now we are using digital technology, digital system, digital processing and digital communication everywhere. Analog systems and equipments and so on are replaced by the digital. So, we are using digital communication everywhere. Okay. So, the advantage of digital over analog also are to be there. Whenever you want to communicate your signal digitally. So, at first I will tell you the block diagram of digital communication system. So, in this what will happen? Initially information source from the information source, information will generate for which you want to do here communication. Next, this is the information. Your every information physically, really is in analog in nature. So, if you want to here digital communication, so you have to communicate this analog information into the digital by using analog to digital converter. Now, this information will go to a source encoder. Source encoder means what? It encodes your information that is coming from the source. That's why its name is source encoder. This source encoder encodes your information that you are getting from the source, as well as it performs the data compression of the signal also, because we know in digital format your data is so high, so big, so large. So, you need here to compress your data. So, source encoder at first it encodes your information that you are getting from the source, as well as it compresses your data so that your information, no information will be lost. इस तरह से कंप्रेस करेगा कि आपकी सोर्स इंफॉर्मेशन जो आपको मिल रही है वो किसी भी तरह से लॉस ना हो. Next, so after source encoder it will go channel encoder. Channel encoder means what? Ki now your digital data you are getting here. So in this digital data 1001, 1001, in this your error controlling task be done by the channel encoder. Error controlling means what? Error controlling means error detection and error correction. That is performed by the channel encoder. Now, it will go to our digital mode as usual. In communication, modulator, demodulator, modulator is a transmitter side and demodulator is a receiver side. So, this is our transmitter side. So, digital modulator we are using here, any digital modulator. Okay. Now, it will go to the channel, your simple channel, and at the receiver side this information, this data will go to our digital demodulator. So, this is our transmitter side. Now, we are at the receiver side. So, receiver side we know digital demodulator will be there. So, digital demodulate your data and this data will go to channel decoder. Here channel encoder at the transmitter side to perform the operation of error controlling task in digital. Error controlling means what? if your digital data is this one 1001, if you are getting 1 instead of 0 or you are getting 0 instead of 1, so your data will be wrong. So, you have to here detection of error, detection. At first you have to detect the error, and after detecting the error you can correct the error. So, channel encoder and channel decoder perform these tasks. What task? Of error controlling task in digital data under the digital communication system. This is very, very important. Otherwise, your data will be lost. You are not getting actual data. So, this is very, very important. That is done by the channel encoder at the transmitter side and channel decoder at the receiver side. Now, source decoder. So, now our information it decodes by the source decoder, and also source decoder means what? It decodes your information originally here as well as it decompress your data, because in source encoder में क्या किया था हमने डाटा को compress किया था. So, here reverse process, decoding your data as well as decompressing your data, and it will go to the your information sink or destination and D to A converter, because your original information was in analog in nature. So, output finally also you need analog in nature. Again you have to use here the reverse converter. Earlier you are using A to D converter in this side. Now, here you have to use digital to analog converter. It means this again this digital information converts into the analog information and get the output. So, this is the basic block diagram of digital communication system. This you have to keep in your mind. In digital communication, these all the blocks are very, very important. They perform their task, then your digital communication will be possible. Okay. So, I think it is okay to everybody. Now, we will see here the advantage of digital communication system. So, effect of distortion, noise, interference, it is much less than in digital signal. Circuit used in digital communication are more reliable. These circuits that I am saying, these are reliable, these are easy to design and cost effective. Flexible hardware implementation than analog. Crosstalk during communication is very rare in digital communication. Now, in digital communication, security also we can provide. This means encryption, decryption technique and compression technique. Encryption means to provide the security. Compression means you compress your data. So, these techniques also employed in digital system, communication system, to provide the secrecy of the information. So, this is the advantage of digital communication. By employing the error detection correction, what? Using channel encoder, decoder, what? You can use error controlling tasks using the channel encoder and decoder. It means you can imply here error detection and error correction. How it is possible? By using the error correcting detecting codes. Then probability of error occurrence is reduced. Obviously, if you are able to detect and correct the error in your digital data, so your probability of error automatically will be reduced. So, this is the another very important advantages. Using multiplexing technique, different data formats, the like speech, video, audio, other data may be merged and transmitted over a common channel. So, these are the some advantages. Now, some limitation this also will be there of digital communication. What? Loss of information also may be occur due to the sampling process. During the sampling, the chances of loss of information will be there. Higher bandwidth you need here. Processing is more complex because you want to design more reliable, feasible, noise free system. So, obviously, if you want to more from anyone, so your system will be having the some complexity. Synchronization is complex. Okay. So, these are the some limitation also of digital communication is there that we can overcome by using new technologies. Okay, further. Now I am taking title of this lecture of random variables. So this is your KEC 601 subject of unit 1. So unit 1 it is for random variables. Okay. So now we start now random variables. So we know we are having generally two types of signal, deterministic and non-deterministic. Deterministic means what? How you can say this is deterministic signal? If you are able to express your signal by any mathematical expression, mathematical derivation, so that will be deterministic signal. If you are able to express your signal by mathematical expression, so obviously it will be predictable behavior and there will be no uncertainty if your signal is deterministic. But in case of non-deterministic or random signal like noise signal in communication system, then what will happen? Why I am calling this in non-deterministic? Because you cannot be express it mathematically. If you are not able to give it into the mathematically, obviously this will be not predicted before actually they occur. And always if you are not predicted, so always uncertainty will be available. So example you can see what you can give, noise interference in communication system. So in communication system, noise is the example of random signal. So if no certainty is there, you are not able to express any equation for those signals, so those signals are random signals. But we have to analyze, we need to analyze these type of signals also. So how? So it is possible to analyze these signals statistically with the use of probability theory. So in this case, whether uncertainty is available, so how? Statistically using the probability theory you can analyze random signals. Okay. So probability means what? Probability means possibilities. So we know if we want to probability of any outcome, so it will be m by n. It means m means number of favorable condition upon n means total number of conditions. So simply I am writing here some points on the probability, because probability is very big chapter for discussion. Okay. For any event we know P of A, any event for P of A it is equal to 1. Always your probability for this 0 to 1. If two events PA and PB are mutually exclusive, so PA plus B is equal to PA plus PB. Okay, you can write PAB, PA by B. So joint probability, PAB means joint probability, PA by B is conditional probability. So some logics, some important I am writing in this PPT about the probability. Why I am giving this one? Because random variable you can analyze statistically using the probability theory. So you should know the some basic of probability theory. Now random variable क्या है वो देखें. What I am writing? I am writing here a random variable is a mathematical function that maps the outcome of random experiment to the numbers. It is a type of mathematical function that maps your outcomes of any event or random experiment into the real number. That is random variable. Now random variable is actually a function, not a variable. क्या है? एक तरह का function है, mathematical function है जो outcomes किसी event के, किसी experiment के आउटकम्स को रियल नंबर में शो करता है. नाउ रैंडम वेरिएबल वी कैन रिप्रेजेंट बाय द कैपिटल लेटर लाइक एक्स, वाई, जेड एंड द वैल्यूज ऑफ दो रैंडम वेरिएबल वी आर रिप्रेजेंटिंग बाय स्मॉल एक्स, स्मॉल वाई, स्मॉल जेड एंड सो ऑन. ओके. So in this way we can represent the any random variable. Now example random variable like price of stock, a student's marks or grade in the exam, average temperature of each day, and so on. Number of heads when tossing 10 for fair coins. Okay. Now I am taking this example. For example, if you roll a die, okay, dice, the outcome is random. You don't know outcome, whether 1 will come, 2 will come, 3 will come, 4 will come, 5 will come, 6 will come. So outcome is random, not fixed. So, but we know there are 6 possible outcomes, each of which occur with probability 1/6. We know 1 to 6, it means, and each having the probability of 1/6. So, these outcomes, if these outcomes in this, if these maps into the here some real number, okay. So, this sample space or possibilities we are mapping into the random real number. So, this is the our random variable. If x is a random variable, so we can represent these possibilities, these outcomes into the real number. That is our random variable. So, random variable x takes a definite set of values with different probabilities. So, different probabilities. Okay. So, roughly probability means what? How frequently we expect different outcomes to occur if we repeat the experiment over and over. Now, this example I am taking, okay. From this example, I am trying to explain you what is the meaning of random variable. So, my random experiment, let's a coin is tossed 3 times. If I am tossing 3 times, so sample space possibilities कितनी होंगी? 2 to the power 3 is equal to 8. It means 3 बार h, hht, hth and this. These 8 possibilities are there. Now, outcome I am supposing here number of tails in the outcome. These are my outcome that I am supposing here. So, in this sample space like hh, hs. Okay. So, here what outcome I am outcome in hh, outcome I am taking number of tails in hh, number of tails are 0. So, what I am writing x hh, okay, outcome in this sample space is 0. In this sample space 1, 2, 2 and for 8 possible combination I am writing thus outcome here. Now, what? These outcomes, okay. So, number of tails and this is our real line. Now, I can map here. So, 0 for this, 1 for these 3, 2 for these 3 and 3 for this. So, what I am mapping here all the outcomes into the real line and this is our random variable. So, in this figure it is clear what every element of the sample space that I am supposing in the example is mapped to exactly one real number. Okay. So, sample space convert or map into the real number and this is the concept of random variable. Now, types of random variable. How many types of random variables are there? So, there are 2 types of random variable. First is discrete, second is what? Continuous. So, discrete random variable means what? So, random variables have a countable number of outcomes. If you are having outcomes that is countable, so it will be discrete, like dead, alive, okay, on, off, dice, number of customer who arrive at the bank from the any particular time and so on. So, if these are outcomes are countable, so it will be discrete random variable. If these random variables outcomes are uncountable, so it will be continuous, like our blood pressure you can count. Can you count? No. Weight, speed of car, okay, and so on. Okay. So, in this way we can categorize our random variable in 2 ways, discrete and continuous. Now, random variable means what? You are analyzing these random variable on the basis of probability. So, distribution of probability is very important. So, you can represent your random variable by using its probability distribution. So, of representing this what? For continuous random variable, we know this distribution or representation is called PDF. PDF means probability density function. Its value P of x, this is actually P of x, its value lies from 0 to 1, and area under the curve, the PDF always would be equal to 1. And this is for continuous random variable. This is for continuous random variable. For discrete random variable, same probability distribution we can represent by using PMF. PMF means what? Probability mass function. Okay. So, always you have to keep in your mind. So, if continuous random variable you have to show in terms of density function, so it will be always PDF, and PDF always show is by the small f fx. And for discrete random variable, it is known as PMF. PMF means what? Probability mass function. Now, you can understand from this example. So, for rolling a die from 1 to 6, all are having the probability of 1 by 6. So, all are having 1, 2, 3, 4, 5, 6, 1 by 6. If you sum up all this probability of these all 6 outcomes, so it will be equal to 1. Okay. So, this is our probability density function. Now, next is CDF. CDF means cumulative distribution function. Cumulative means what? The increasing, in the increasing steps, okay, you have probability distribution. So, that is our CDF. So, CDF, and it is always represented by capital F of x. PDF is represented by the small fx, but always your CDF what? It is represented by the capital Fx. It is what? It is an increasing step function with steps at the value taken by the random variable. 1 plus 2 plus 3 plus 2, 5 plus 2, 7 is okay. So, that is our CDF. Now, the properties of CDF. So, CDF always greater equal to 0 because you are adding, you are summing up your values here. Okay. So, always equal to greater than or equal to 0. If at the last point we can see, so it will equal to 1 and minus infinity is 0. Okay. So, if x1 is less than x2, so obviously the CDF value at x1 will be more than, will be less than x2, okay, because CDF is what? This function. Here your values are adding, okay, जोड़ रही हैं, add हो रही हैं. Now, continuous random variable. So, continuous random variable, if you want to represent in terms of probability distribution, so always by using the PDF, probability density function. It is always represented by small fx for continuous random variable. For discrete random variable, it is again if fx, but this is called PMF, probability mass function. Now, CDF give useful information about a discrete and continuous random variable. So, your both type of random variable, whether it is discrete or continuous, always CDF will be same, but PDF it is for the continuous random variable, and similar concept for discrete random variable is called probability mass function, and always your PDF is equal to first differentiation of CDF. So, PDF is defined as the first differentiation of CDF. Now, the value of PDF. So, always its value will be equal to or greater than 0. So, its value always will be positive, it is non-negative. Area under the curve from minus plus infinity is equal to always 1. Now, from A to B, if I want to get the PDF from A to B, so it will be area under the curve from A to B for particular limit. So, these are the properties of PDF. Now, these are some examples. From these examples, you can understand how you calculate, how you identify whether the function is PDF or not. So, from the properties you can do it. Okay. So, here now in this question you have to find out the value of k for which following function whose valid probability distribution is this. So, this PDF is given in the question, that is fx is equal to kx square plus 1 from 1 to 4, otherwise it will be 0. We have to calculate here what? We want to calculate the value of k. So, from 1 to 4 kx square plus 1 into dx, okay. We know what? It is equal to 1. What? In the last time what? This, okay. For the particular limit or this total area under the curve equal to 1. So, here our PDF lies from 1 to 4. So, limit from 1 to 4 kx square plus 1 dx is equal to 1. Now, you solve the integration and get the value of k, that is 1 upon 24. Now, if you want to calculate x is equal to 3, so you have to put here x is equal to 3, because you are now you are having the value of k. Then 2 to 3 you want to calculate PDF here. So, 2 to 3 again in this expression you can write, because you are having the value of k now, and you will get the value. So, similarly you can easily recognize, identify and calculate the at the different points the value of PDF probability and so on. That is asked in the question. Now, another question, CDF is given to you. Okay. So, from 0 to 4 it is this, from whenever x greater than 4 it is 1, otherwise it will be 0. So, calculate the probability from 2 to 3. So, this is CDF, capital F it means CDF, small f means PDF. Always you have to keep in your mind, do not be confused here. CDF means you are adding up your probabilities. In this question you can also calculate here from 2 to 3. So, CDF value at 3 minus CDF value at 2. So, CDF value at 3, it means x, you have to put x is equal to 3 here, and f of 2, it means you have to put x is equal to what? 2 here, and your value will be 11 by 32. So, in this way easily you can calculate the value of CDF as asked in the question for a particular limit. Now, if you have to determine your value of probability whenever your x greater or equal to 1.8. So, how you calculate? You know overall summation is equal to 1. So, the value of at 1.8 is what? 1 minus CDF at 1.8. So, 1 by 32, x is equal to 1.8, you have to put here and you will get the value of this. So, in this way you can easily solve the question of PDF and CDF, and there are so many questions. Now, we are coming on joint CDF. Joint means if you are having two different random variables x and y. Okay. So, if you are having x and y, two random variables here, then what will happen? And you want to join these two random variables by using the joint CDF, like f of, जैसे joint probability होती है वैसे f of x y. Okay. So, that will be joint CDF. Similarly, joint PDF and so on. Now, in the properties are same like CDF. Joint CDF means what? You are combining two random variable here. The properties are same like in CDF. So, first is here it will be non-negative, it will be increasing stepwise function like non-decreasing, and continuous function in xy plane, because now you are taking the joint CDF of two random variable x and y. Similarly, joint PDF, if x and y are two random, joint PDF will be like it will be f of small f x y, and that is what will happen? Second differentiation of, partial differentiation of with respect to x and y of CDF f of x y. So, in this way you can give the mathematical formula that shows the relation between the PDF, joint PDF and joint CDF. Okay, what I am writing also here, It is partial derivative of joint CDF with respect to two random variable x and y also. Okay. Now properties are same. This will be non-negative. The total area under the curve joint PDF also equal to 1, like Pxy dx dxy is equal to 1 for a particular limit, like minus infinity to plus infinity. This is okay. So that you have to keep minus infinity to plus infinity. Okay, you can remember it. This is minus infinity. Now statistical averages. Now these are the characteristics of random variable. Now what I told you the representation of random variable by PDF, CDF and so on, and calculation of those. Now the some characteristics of random variable that you can represent, you can say in terms of statistical averages, like its value, like mean, average, expected value. First characteristics of statistical value. So it is the first moment of random variable x. Similarly, if you are taking the second moment of random variable, okay, that is called what? Its mean square value. Third moment, fourth moment. Similarly, nth moment of this. Okay. So this is called what? E of first moment E of x. Second moment E of x square. This is the expected value. Nth moment means E of x of y. Similarly, central moment, okay, variance, standard deviation. So these are the some characteristics or statistical values of random variable by which you can represent your random variable in more efficiently in terms of its mean, average, expected value. These are the same. Means, average, expected, these are one. Mean you can also say average, you can also expected value. Okay. So this is from my side, and more things are available about this that I can tell you. These are the some example for calculating if some PDF is given to you. So you can find out its mean, its variance, its mean square value and so on. So some formulas are there by which you can calculate. Like in this example, x is random variable, its PDF is given to you. This is 2x minus 2 from 1 to 2. So you have to calculate mean, variance and so on. So mean, what is mean? E of x is equal to, this is the formula, x into PDF dx. X into PDF kitna diya? 2x minus 2 from 1 to 2. You have to solve here, so your answer will be 2 log 2. This is your mean. Now variance, we know the relation between the variance, mean square value and mean whole square. So at first your mean square value, this is x square fx dx, you solve, it will be 2. Now you put in the relation, your variance will be there. Similarly, you can easily solve any question or you can calculate any statistical values if PDF of any random variable is given to you. Okay. So these are very, very easy. Okay. So this is from my side about random variables. I hope you all understand about the random variable, its basic and its concept. Thank you very much. Jai Hind.